This screencast applies the concepts learned in Chapter 2, Reactors, to the chlorobenzene production plant started in Chapter 1, Introduction to Aspen Plus. To begin, open your chlorobenzene production plant simulation you saved after Chapter 1. Go to the simulation environment. Create an RCSTR model for the main reactor and rename it as such. Enter two feed streams, one for chlorine gas and one for benzene. Create two product streams, a vapor and a liquid. Label all streams appropriately. A small amount of hydrogen chloride will dissolve in the liquid product stream, and if left unattended will corrode downstream unit operations. To remove the corrosive agent, we will use a washer unit to neutralize the hydrogen chloride with sodium hydroxide. To model the washer unit, create an R-stoic model. Connect the liquid product stream from the main reactor to the washer and add a caustic feed stream. There will be a waste stream in which the neutralized salt will exit in a crude process stream which will continue on to the separator units. Press the blue next arrow to enter information about the benzene feed. The reactants will be fed to the reactor at the design specifications of 55 degrees Celsius or 328 Kelvin and 2.4 bar. Subsequent tutorials will show you how to bring the feed from room temperature and pressure to these operating parameters. Input a total flow rate of 200 kmols per hour with a mole fraction composition of 0.95 benzene and 0.05 water. Press the blue next arrow to enter information about the caustic feed. This will be fed at room temperature and pressure. The total molar flow rate is 25 kmols per hour with a molar composition of 0.1 sodium hydroxide and 0.9 water. Press the blue next arrow to enter information about the chlorine feed stream. The feed parameters are the same as for benzene. 328 Kelvin and 2.4 bar. The total molar flow rate is 500 kmols per hour with a mole frac of 1. The next information to be entered is for the reactor. Enter the operating conditions of 2.4 bar and 328 Kelvin. Choose the valid phases as vapor liquid and specify the resistance time as 0.5 hours or 30 minutes. On the Streams tab, label the two product streams in the appropriate phases. At this point, we need to specify a reactor set. Enter the two reactions detailed in the problem statement at the end of Chapter 1, Introduction to Aspen Plus. Assume both reactions are first order with respect to benzene for the first reaction and monochlorobenzene for the second reaction. Chlorine is 0th order in both reactions. On the Kinetics tab, enter the K value as 0.00015 inverse seconds and the E value as 1.3 joules per kilomole for the first reaction. Enter 0.0001 inverse seconds as K and 0.9 joules per kilomole as E for the second reaction. Press the blue next arrow and add the R1 reaction set to RCSTR. Pressing the blue next arrow brings you to the washer. Enter the operating conditions 328 Kelvin and 2.4 bar. Change the valid phases to vapor liquid dirty water. Go to the Reactions tab and enter the neutralization reaction as shown. Enter a fractional conversion of 1 for hydrogen chloride. Save the file where it can be accessed later. Watch the following tutorial screencast in Chapter 3, Separators, to continue the series. For more Aspen Plus tutorials, visit the Lafayette CHBE YouTube channel.